guys, welcome to Knifemaking Tuesday, week 29. I'm John Grimsmo, this is my brother. I want to say that you're my brother, because otherwise people think we're gay.
I'm Erik Grimsmo.
We're going to put that in?
I don't know.
Anyway, my brother. We stayed up late last night making 3 blades. We made these, one by one on the fixture to test the code, make sure that they work. Each one's a little bit better than the previous one. So now we think we have a code that works and is good and can be multiplied over 11 different blades. As you can see here, the fixture is set up with 11 blades. Notice in the bottom left-hand corner there's one missing because we kind of goofed it up. My lovely hand model, Erik. Yeah, we kind of goofed that up. So we're left with 11, which is totally cool. Doesn't matter. And we are ready to run it. Probably not going to need that. Just for the drilling. Hey! What? It was backwards. I don't know why it's backwards. Even on the screen, everything says go left ways, not right ways. I don't know. I goofed up. No surprise. Here's the problem. As you can see, this is basically all the tool paths. Right now the machine thinks it's at 0, 0, which it is, but it thinks 0, 0 is right there, when in fact it's supposed to be up over here. And what happened was, when I wrote all my subroutines, see how it says G52, X negative 5.5, X negative 11, Y negative, this basically copies and repeats every code over and over and over. Anyway, the X's are supposed to be positive, not negative, because they're supposed to go this way, not backwards. So all I have to do is change the code and take all the negatives out of the 11. Should be good to go. See, that's much more like it. X0, Y0 is up in the corner. It's missing the one where it's supposed to. Looks just like that. X0, Y0 being up here in the corner. Much better. Let's hit it. So this first operation is drilling all the pivot holes. I have them water jet undersized, so it's drilling them out a little bit bigger. And then I'm going to ream them to about 0.177. Yeah, that didn't clear. I'll fix that.
Hit the bolt?
Yeah, it didn't retract high enough. Oops. Well, it's learning mistakes like that that end up costing me a lot of money, but luckily the drill bit is a very cheap item. Basically what happened was in the subroutine for the drilling, at the end of the subroutine file, it does not retract very high. So instead of retracting and going to the next one, it sort of tapers up to the next one. And the bolt got in the way. And that could have been a big problem for an end mill, a reamer, could have cost a lot more money. So I just changed the way the subroutine is created, so at the end of a drilling cycle it goes up and then moves to the next one, instead of tapering up. So that should be all fixed now. Hit it and run it again. Just going to re-drill these holes, but that's fine. Luckily all these holes are getting reamed bigger anyway, so having them drilled twice is no big deal. And so you can go So it finishes the drilling, the little cycle of itself. You can see it goes up to the end of the drill cycle and then rapids up right there. And then moves to the next one. Perfect. Now moves to the next one. It'll keep repeating this over and over again. Boring. Switch to the reamer. Now that toolpath was a little weird, how it stopped here at the end of this subroutine and then moved back to 0, but it worked fine. While I've got your attention, hi. I want to give a huge shout out again to Bob Warfield at CNC Cookbook for writing G-Wizard. It's amazing. Not only does it calculate your speeds and feeds for you, it saves tools. Because I'm an untrained machinist, I never went to school for this. I'm learning as I go. You know, I don't know how to calculate speeds and feeds. It's all guesswork for me. And I broke a lot of end mills and spent hundreds and hundreds of dollars learning mistakes. And then you plug it into G-Wizard and find your correct speeds and feeds, and oh my goodness, the tool is lasting, you know, for weeks. Whereas before, you'd go through them every few days. So, way less broken end mills. It's awesome. One of these days, I think I'll do a specific video just for G-Wizard. And show through the process of creating some speeds and feeds and actually using them. Yeah, I thought about it. Sorta. I'm sort of not done my lunch. But, you gonna go have some? So right now we're just roughing out the blades. Putting a large stepper over on them just to get most of the material away so that we can take them to heat treat as soon as we can. And then after heat treat, we'll put them back on and put a really nice finish on them. However, this finish looks really, really nice as it is. So, but I think we're going to go with the heat treat route, the hard milling route, and get an even better surface finish. I got something to show you guys. Fa-chink! Fa-chink, 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 chink, 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 chink. 14 blades, done. Wow. See, this is a rough grind pattern because they're getting hard milled after heat treating. So you don't need to have it look super pretty before heat treating. Just got to get the material away. So there's the rough grind, and here's the finished grind, what they're basically going to look like. But all of these are rough ground, rough machined, and then they're going to look like that at the end. And actually the grind is going to come a little bit higher and a little bit more in on the front edge here. You see that apex right there, where the arc meets the flat part? That's where the grind's going to go to once this is all said and done. So it's going to be really high ground, recurve, hollow ground, machined knife. One thing that's sort of bugging me about this subroutine massive batch of knives that I just did was that if you see this first one has nice jimping, got machined. All the other ones did not get machined for jimping. I don't know why. And the thumb stud, this has a nice hole for the thumb stud screw. all the other ones did not get machined for thumb stud. It's like that tool never happened. It is in the code, it says change the tool, the code is there, it just didn't happen. I don't know why yet. But luckily I can put these back on the fixture and machine those bits, no problem. So once I figure out what happened. So yeah, we got 14 of these bad boys done already. 3 were the kind of prototypes that we did, and then just finished a batch of 11. Going to start another batch of 11 today, and send them off to heat treat. Today's Friday, probably Monday. We'll go over to the heat treat place and hopefully get a rush job done there.
Hey guys, Erik here. I just wanted to talk to you about what I did today. I sharpened this blade. We've had it sitting around dull for quite a while. Just been playing with it, flipping it around, and I figured I needed some practice to, see if I could sharpen the recurve and the front nosy part. So yeah, I gave it a shot, and on the wicked edge, the recurve was not a problem at all. That thing is quite awesome, but I did have a little problem just here. It doesn't seem as sharp as the rest of it, and I'm not sure if that's because of, we have the flat stones, and if they just hit the wrong angle at the front, but I'm working on it. We'll see what happens. And this blade did have, some chatter issues back in the day. But with the new mill, we just made 40 some odd blades, and they're gonna be awesome, way better than this one. So just stay tuned, and see you later.
Check it out. 42 Norseman blades, roughed out, ready for heat treat. We have been busy people. Here's the first 3 prototypes we did. That's pretty much what the grind is going to look like after hard milling, but for rough milling we roughed it out to like this, and then we'll get them heat treated and then hard mill them to a finer step down. Pardon my stuffly voice, I'm suffering from hay fever now. Anyway, 42 blades made on the Tormach. I freaking love this machine. But Erik just said he sharpened this bad boy, and he just did a little cut test and is very happy. Oh, it bent. Try a firmer. What were you saying about that recurve?
The recurve is awesome.
It's a very slight recurve, but
it just has enough to kind of hook what you're cutting.
Well, it's funny because we've never had a sharp Norseman.
No.
So we've never actually cut anything with it. I couldn't see it from that angle. Oh. Try this corner. How about slice the top off? Cool stuff. RWL 34.
Doesn't seem to have really affected the edge either.
Yeah, oops.
Destroy this.
Good. How, what stones did you use on the wicked edge?
All of them.
No, but what do we have? We have up to 800?
Up to 1,000.
We have up to 1,000, okay. So that we don't have any strops yet or any ceramic stones. We got to get some of those, but
yeah.
I still find the edges kind of toothy.
Yeah, for cutting paper, it kind of, you can tell it grabs just a little bit.
Yeah.
But it's obviously super sharp.
Yeah.
It's just not a nice polished, stroppy edge.
Yeah. Well, for some things you want a toothy edge, but I think for a knife like that, I would prefer it if they were all mirror polished, but
Yeah.
We just don't have those stones at the moment, so the first batch is going to be 1,000 grit edge, which there's nothing wrong with that. So the next project for the next 3 days is to turn this pile of titanium Norseman handles and clips into mates for these blades. So we have a roughed out fixture plate. The handles are on it, the bolt holes are here, the liners are in. Just got to drill and tap and whatever for all the mounting holes. So I'm going to use one fixture to do the handles, both sides, and to do the clips as well. So we'll be doing that next. Got all my blades done here, 42 of them. Taking them off to heat treat right now, so I'm just going to put them together and drive out there. So I dropped the blades off at the heat treater, Allied Heat Treat in Mississauga. Excellent people, excellent price, they know exactly what they're doing. Couldn't be happier. I was in and out in 3 minutes. And he said they'll be ready in 3 days. So on Thursday, I'll go pick them up. Next up, making handles. So a potential problem just occurred to me. I'm designing my handles right now to be cut, the new handles, and the part where I drill and ream the stop pin. The blades are at heat treat right now, so I didn't even keep one. I should have kept one. I'm an idiot. Which means they're at heat treat for the next 3 days, and in that time I need to make my handles. So I don't have a blade and handle to be able to put together and make sure that the stop pin slides freely and doesn't bind and is lined up right and is timed right. So I'm taking quite a bit of a gamble making all my handles with no blades to be able to test. And if there's something wrong, I'll have to change it after the fact, which is no fun. But that's what I have to do. And hopefully with the accuracy of my CAD work and the accuracy of the Tormach, it should be perfect, but yeah. So here's something else I just noticed that's going to be a bit of a problem. I'm designing my handles right now, writing the code to cut them out. You can see there's a loopy right there. Anyway, when I have both the handles flipped to have the backside showing, you can see these are the water jet outlines. They overlap, and that's going to cause some serious interference. So you see these two outlines, here is one and then here's the other one. They don't fit. They overlap and they're not going to work like that. And I didn't think about that. I didn't try to actually flip the parts, because you see how the butt of the handle comes out like that, and they just take up the same space. Unacceptable. So what I'm going to have to do to fix that is, instead of flipping both of them backside up and machining them like that, I'm going to have to do one backside up and one front side up and machine them like that, and then flip them each, sort of do them opposite of each other, and that'll clear. But you can see I'm just trying to stuff as many things onto one fixture as I can, and because of that I'm running out of room. But I can do 9 pairs of handles and I'm really happy about that. And you can see I'm doing the clips on here too, sharing some of the holes, making some new ones too. So I think I can do 24 clips. I only did the first row and the second row. I didn't bother doing it for the third row. So it's coming along. And for some reason, you can see it's a nice diamond pattern, except for some areas here. I don't know why. It's not going to be like that when it gets machined, but it's just the way the drawing gets rendered. It skips those lines. I don't know why. Well, duh. I think I figured it out. It works much better to flip the parts up and down on their own axis, as opposed to left to right. I have an old habit of flipping everything left to right. But then Erik comes here and starts working, and his natural habit is to flip things up and down, because then you can use the exact same bolt hole, and you just flip a thing forward as opposed to long ways, side to side. So if I flip these forward, you can see that one to that one, they're opposite, and that one to that one, they're just flip forward. Then there's plenty of room to clear, and it doesn't create any clearance problems at all. So I'll just do it like that, and then I can machine both the back sides at the same time like I want to, use the same tools. It's a bit more efficient that way. Alright, so it's Wednesday now, technically after my Tuesday deadline, but I wanted to get some handle material in this video while I could still get it in the video. So here's been my testing so far. Got it bolted to my fixture. These are the back side of the handles. Notice the bearing pocket, stop pin hole, bearing pocket, lock bar slot is water jet. Engraving. Engraving went a little deep, so it's kind of nasty on that side. But on this side, a little bit shallower. Must be tapered or something. It looks perfect, so I'll just cut down the depth a little bit. So I think the parts are actually a little bit bowed up in the middle. I can hear a little bit of slapping there, but when there was coolant underneath and I did that, I could see coolant kind of squishing out a little bit. So call it a 1,000th or 2,000th of bow, which is really nothing, but when you're only engraving down 3,000ths of an inch, you know, that becomes 3,000ths here, 5,000ths here, or something like that. That doesn't make sense. It would be higher here, not here. I don't know. I'm going to cut down the depth. It'll be fine. So one big problem I had is I snapped off an end mill in there. I gave Erik a quick piece of code because I was going to drill out these frame holes. These are where the spacers go. So late last night I gave Erik a quick piece of code and I said, okay, quick run this. And instead of using an 1/8 inch drill bit like I should have been using, because I didn't have one, you know, already set up in the tool table, I already had an 1/8 inch end mill, so I'm like, okay, just use that. So I wasn't here when it happened, but he said it went down and started making sparks, funny noises, even with flood coolant, and just sheared off. So now it's completely welded in there. The handle is sort of toast. But what I'm going to do to save this set of handles is just drill a new hole right beside it. And I'll do the same for the other side, drill a new hole right beside it. So the handles will have one set of funny holes that just go nowhere, but this will be like for a family member or something like that, someone that doesn't care. So I'm basically going to rerun these handles. I wrote new pieces of code, new techniques and stuff, so I'm going to run that and drill these holes, drill the detent ball, and drill and ream the lanyard hole. You don't have to ream it, but I have a reamer that I'm doing for this hole anyway, so I'll just do them the same. And then after all that's done, we can flip them over and start working on the top side. Now, just looking at the handles, even the finished ones that I have, I'm like, oh, the back side's easy, the front side's going to be the complicated part. Not really. The back side uses way more tools and more operations. I think I haven't counted, but there's probably 15 different separate codes used to do this. Drill this side, blah blah blah. And the last thing I'm going to do, I forgot to mention before, is drill 2 holes here and 2 holes here and tap them for the clip, pocket clip. So here I've got the tension compression tapping head with this is a 256 thread form tap. Anyway, notice how there's no reliefs in the threads up and down. It's just a constant, it looks like a screw basically. And instead of cutting the threads, it basically displaces the metal, and it just shoves its way down there and swells up the metal a little bit. It's supposed to be better for CNC. Don't break as many taps, etc. And for such a small tap, I mean, you can see how small it is to my finger. Don't really want to break these. They're like $15 each. So I'm going to try to do that. Small complaint with this tool is that it's super wobbly. And when you're trying to match a hole that's not very big, it's got to find its way in. But that's just the way it is, because there's a lot of spring mechanisms in here. Really hard spring going up, soft spring going down, to soak up any slack. So that's just the name of the game. You could do what's called rigid tapping, but that might break taps even more. So moving on. Here's a quick shot of my tool holders. For this set of handles, I haven't counted, but probably 5 to 10 tools. Some really small drill bits. This one's even smaller. For doing the detent hole and the pre-drill for this tap here, I need this drill, 171 drill. I need a 1875 reamer. I need, not that guy, I need this guy. 1/8 inch 4 flute end mill. 9. Here. This is the one I use for engraving, 1/16 ball. Anyway, lots of tools, lots of tool changes, but the beauty is it remembers them all. So the first one I need is tool 29, because program's telling me T29, H29. So tool 29, hit the foot pedal, plop it up, boom, and then we hit go. It's probably going to put coolant on. Put my shield in. Sounds perfect. Now I've already drilled this hole, so it's not really going to do anything, but so I'm going to do the same to that one. I've already drilled this hole, big deal. But this lanyard hole in the back I haven't drilled yet. You hear that? That's how a drilled hole is supposed to sound like. Just the tiniest bit of squeal and then practically nothing. Next up, telling me T11, which I believe is this 3/16 reamer. Take these off. There. Put that there. There we go. So in the handles right now, I'm trying to drill this long, tiny drill bit. It's a number 54 drill bit, which is about 55 thousandths of an inch. You can see how utterly tiny it is. This is a jobber length, so normal, like full length. And I just broke 2 of them in a row. They're basically too long. Like, I spotted the hole so that it's got a place to go, but it basically just gets pounded and snaps right off. So the cure for that is I'm sending Erik out to the tool store right now to buy short ones, stub drills, or also called screw machine drills. A little bit shorter. The one that I'm showing here is a different size diameter, so that doesn't work, but a little bit shorter, a little bit stouter. Hopefully it won't have this problem. So after breaking 2 of those drill bits, I'm just going to forget about that little piece of code, move on to the next ones, more drilling and reaming, and finish this side of the handles, and then deal with that D10 hole later. Currently this set of handles has a piece of broken drill bit inside, but luckily with titanium it's very resistant to acid, so I can soak it in ferric chloride, and it should dissolve that drill bit and let me punch in the D10 ball. I bet you it drilled deep enough to begin with, so that one's probably still savable, luckily. And then I'll do some more testing before I do a big run of them and keep breaking drill bits. So right now I'm drilling, I forgot to offset it. So now I've got my tapping head in the holder. A little nervous to do this one. Such a small tap. Thread forming tap, that's what it's called. Wait, is that what I called it before? I don't know. Roll tap, thread form tap. Anyway, let's try it. Hey. Nope, broke it right off. Son of a crap. I wonder if the tap is just too small for the run out, the eccentricity of that thing. See how much it wobbles? So the tap is actually in there. That means it made the hole, found its way in a little bit. Man, I tell you, this piece of titanium is just taking a beating. It's got a broken 1/8" end mill, a broken 256 tap, and a broken number 54 drill bit. All in one piece. Okay, I decided to forget about the tapping for now, move on to the other operations, make sure that everything else works. So that at least I have a list of specific things that suck. And I get to test all the other stuff, so let's do that. Luckily everything else worked great. It was just a matter of recutting that pocket, the stop pin holes. I've already done that once, but it was good to see the code do it again, just to make sure everything works. So basically, for the back side of the handles, most things work. I got new drill bits coming for the lock D10 thingy. I can't seem to tap that. The clip holes, which sucks donkey. And this 1/8" end mill problem is fixed. So, tapping problem, hopefully the new drill bits will fix that problem. So Erik just got back with new drill bits from the store. Notice the long one versus the short ones. Quite a big difference, especially when you can chuck it up to here or so. You can see how much less is sticking out. Hopefully they work. Okay, I think I figured out why this keeps breaking taps. Well, why it broke one tap anyway. I talked to Tormach, and they said basically tension compression head is not really rated for such a small tap at 256. They only like to take it down to 624 or whatever thread that is. And basically what happens is, because there's a spring tension pushing it down, as it's going into the work, it has to press on that spring pressure, and it's basically crushing the tap because it's so small. So that's why. Which makes total sense. They have another style of head that's not spring loaded, but it's got a reversing clutch inside. So as it goes down, it feeds one way, and as you pull it back up, it reverses and feeds the other way. That would be a much better solution, and that's kind of what all the other knife makers use. And you can do that on a drill press, so they're pretty cool. However, since I don't have one of those, and I can't get one in the next few days before Blade Show, what they suggested was to pre-drill it for a bigger size drill bit. So right now I'm using a 73 thou drill bit. I have a 78 thou in stock. I have a 1. So I'm going to try that, which means there'll be less thread engagement, less pressure, less force. It might work. And since they're just for the clip holes, you don't need a lot of thread. So there's your problem. So I almost forgot. The other thing they recommended was to use an actual tapping lubricant and not just the coolant that comes with the machine, because this stuff's much thicker and it's like honey, and that should help save taps as well. So all of those tricks combined should help me tap some holes, because I have a lot of holes to tap. So I just drilled another D10 hole at what the heck size was it? 55 thousandths of an inch, I think. And with the new drill bits, it worked great this time. The other thing I realized was that my speeds and feeds were quite aggressive. The program I used to calculate everything, G-Wizard, there's a setting where you can set it from tortoise to hare, as in how fast everything moves in relation to each other. And for everything on this knife, I kept it on the hare setting, the fastest one. But for a little drill bit like that, it's kind of stupid. So I turned it all the way down, or almost all the way down, and now the hole drilled perfectly. It cut the feed rate in about half, so it works much better this way. Okay, here I've got tapping head back in place. I'm using this Ultra Lube stuff. I've already put a good wadge of it on the tap there. Bigger hole, a little bit more accurate spindle speed versus feed rate, and proper cutting lube, no coolant. Let's see if this works. Again, I'm nervous. Alright, come on, you can do it. You can do it. Hey, get centered for one. Okay, I found the hole. Okay. Ah. Okay, that barely worked. What happened was it's not reversing very well. Okay, if I have to go in there and kick it backwards every time, that's okay. I feel like I should get some more on there. I can't though. Okay, put some more on with my finger. Yeah, the threads are so fine it's not actually reversing itself. And okay. Yay, it worked! Oh, that makes me so happy. Notice there's a huge delay between holes. I'm using a G84 tapping routine that Solid Cam provides. So it's just like a drilling cycle basically, but for some reason there's a stupid like 5-second dwell in between each one. That's okay. That worked extremely well. Extremely well. I'm so happy. And if I have to go in there with my hand and kick it backwards every time, I don't care because it really doesn't take that long per hole. Okay, that's good. That's good. Moving on. That means that... No, the back sides are almost done. Not quite done. Oh, yay! Alright, already. Next tool. Tool 21. 21, where you at? Gotcha. Go. We're going to want the splash guard. Can you see? Not really. Is that better? So now I'm using an endmill actually to make a hole for the stop pin. It gives me a nice flat bottom to the hole, and then I'm going to ream it after that. Tool 10, 3/16 endmill. This is going to make the bearing pockets. I could just as easily do that with the 1/8" end mill, but it's way faster with this bigger end mill. Left a pretty healthy burr. Pretty healthy burr there because if I remember right, this end mill is extremely dull from cutting 42 blades. Doing the profiles on that, so I need to replace that end mill before I do a big run, but otherwise worked great. What's next? Tool 12. 12, reamer. Reamer. It's a 5/32 reamer. Ream out the stop pin holes. Notice they're really slow RPM. That's perfect. I love how reamers sound. I don't know why. I don't even know if you can hear that. It's just the tiniest little squeal. You can tell it's working, but not working hard. And that's it. Back side of the handles are done. I haven't even started coating the front side of the handles yet. So I don't know if I'll get to that in this video, but progress is being made, my friends. Booyah! Those tapped holes work awesome. Oh, good to know. Those screws are the exact right length, so I don't have to shorten them. That saves a lot of work. But yeah, there's my pocket clip. I put a good kink in this one because I'm an idiot and I bent it in a hurry. Trying to bend it for a little bit of preload, but now it's got a little kink in it. Oh well. This one's for me anyway. But yeah, pocket clip, yay! That's the first time I've ever bolted a pocket clip to a Norseman. Because I've never been able to tap a 256 hole. Yay! I tried it in my pocket, it works awesome. It works really, really good. Okay, now it's time to run a whole batch of these backsides. I'll do them all in a batch, and then while Erik's running that, I will write code for the top side. Do my corner rounder, profile the outside, pocket the thingy, cut the lock bar, and on the display side do the sculpted texture. So all the knives are going to be smooth on the back, not grippy. It's just the way it is. But yeah, so I'm going to cut it here for this week. Thank you so much for watching. Next week's video will be basically everything up until I leave for Blade Show, because I'm leaving Wednesday morning. So the next week's video will be, yeah, everything I've done up until I've left. And I'll post it probably Tuesday night, maybe Wednesday morning right before I leave or something. Alright guys, thank you so much. Take care, bye.